This job aid is designed to help you describe and record chemical responses in the soil. Chemical response is the reaction of a soil sample to an applied chemical solution or a measured chemical value. After viewing this video, you should be able to use guidance in the field book for describing soils and other technical references to collect and describe soil reaction, or pH, effervescence and calcium carbonate equivalent, reaction to reducing conditions using alpha-dipyridyl dye and test strips, salinity, and odor. Before you get started in the field, take time to review the relevant sections of the Soil Survey Field and Laboratory Methods Manual, Soil Survey Investigations Report number 51, version 2, issued in 2014, Field Book for Describing and Sampling Soils, version 3, issued in 2012, National Soil Survey Handbook, part 618, and Soil Survey Manual, chapter 3, issued in 2017. Summaries of the methods are provided, along with any interfering conditions and safety considerations. Also note the equipment list, detailed procedure, and how to report measurements and classes. Chemical responses are used to identify the presence or absence of certain materials, to obtain a rough assessment of the amount present, to measure the intensity of a chemical parameter, for example, pH, or to identify the presence of chemical species, for example, ferrous iron in the soil. Flip through the pages of the field book to review what can be recorded. pH, effervescence, reduced conditions, salinity, and odor. Soil pH tells more about a soil than merely indicating whether it is acidic or basic. The pH of a soil must be determined for an understanding of important chemical processes, such as ion mobility, metal-ion equilibria, rate of precipitation and dissolution reactions, nutrient availability, toxicity of trace metals, and the negative response of many plant species to soil acidity. Soil pH is defined as the negative logarithm base 10 of the activity of hydrogen ions in a solution. A soil with pH 5 is 10 times more acidic than a soil with pH 6, and 100 times more acidic than a soil with pH 7. Soil properties that affect soil pH include parent material, time, climate, organisms, relief, saturated hydraulic conductivity as relates to soil leaching, kind and amount of clay, nature and type of organic matter, amount and kind of exchangeable cations and anions, soil to solution ratio, salt or electrolyte content, and carbon dioxide content. Soil pH is measured with a pH meter or pen, indicator solutions, test strips, or other kits. Different soil pH tests include 1:1 water pH, the most common pH method for mineral soils. 1:2 0.01 molar calcium chloride pH, the most common pH method for organic soils. However, it can also be used for mineral soils. The calcium chloride pH is generally less than the 1:1 water pH. The calcium chloride pH diminishes the seasonal effect of soluble salt concentration. Taxonomic criterion to distinguish reaction classes in mineral soils, such as entosols: acid with a pH of less than 5, or non-acid with a pH of greater than or equal to 5. Taxonomic criterion to distinguish two family reaction classes in histosols. Disic families have a pH of less than 4.5 in all parts of the organic materials in the control section. Uic families have a pH of greater than 4.5 in some part of the control section. Saturated paste pH. Used in regions where the soils have soluble salts, the saturated paste pH is compared to the 1:1 water pH and the 1:2 calcium chloride. The usual pH sequence is 1:1 water pH is greater than 1:2 calcium chloride is greater than saturated paste pH. If saturated paste pH is greater than 1:2 calcium chloride, the soil is not saline. If saturated paste pH is greater than or equal to 1:1 water pH, the soil may be sodium saturated and does not have free carbonates. 1. Normal sodium fluoride, used to identify andic materials and is diagnostic criterion for the isotic family mineralogy class. Sodium fluoride with a pH greater than 8.4. Oxidized pH. Most mineral soils with pH less than 3.5, or in which pH drops to less than 3.5 after prolonged drying, typically contain acid sulfates. The oxidized pH test can determine if known or suspected sulfitic materials will oxidize to form a sulfuric horizon. Hydrogen peroxide can also be used to detect sulfitic materials, especially in subaqueous soils. Monosulfides are present if the soil color changes after adding a drop of 3% hydrogen peroxide solution. A soil color change after adding a drop of 30% hydrogen peroxide signals the presence of pyrite. If these soils are drained or oxidized by construction activities, the soil pH could drop to 3.5 or less, making the soil unsuitable for many uses. In all cases, record pH reading and the method to the precision limit of the method used. Effervescence is the gaseous bubble response of soil to applied hydrochloric acid, hydrogen peroxide, or other chemicals. One normal hydrochloric acid is used for the carbonate test. Apply a drop of acid to the soil matrix to determine the effervescence class. Note that acid applied to carbonate masses should be recorded separately as concentrations. Sometimes it is necessary to measure the calcium carbonate equivalent contained in a soil that effervesces for purposes of soil classification. Carbonate content of a soil is used to define carbonatic, particle size, and calcareous soil classes, and to define calcic and petrocalcic horizons. A field procedure was developed to measure calcium carbonate by using a simple volume calcimeter from a 50 milliliter and a 20 milliliter plastic syringe. Chemical dyes, such as alpha-dipyridyl dye or even indicator test strips, can be used to identify ferrous iron in hydric soils and aid in conducting wetland delineations. To meet the hydric soil definition, a positive reaction to alpha-dipyridyl dye must occur within 60% or more of a layer in at least 2 of 3 samples, occurring within a 5 centimeter layer in upper 10 centimeter in soils that inundate but don't saturate, a 6.25 centimeter layer of the upper 12.5 centimeters in sandy textured soils, or 10 centimeters of the upper 30 centimeters in all other soils. Soil salinity classes are based on electrical conductivity from a saturation paste extract as decisiemens per meter. EC may also be measured at various soil solution extract ratios. The resultant EC values are not directly comparable because of the dilution effect. The salinity standard is the saturated paste extract EC. To avoid confusion, saturated paste EC is commonly denoted as ECE, and other extracts denoted by the dilution ratio. Field measures of EC can also be obtained by electromagnetic induction, or EMI, and salinity probes. These measurements obtain an EC value that depends on salinity, moisture content, mineralogy, and texture. Again, these measurements are not directly comparable to ECE, or EC of any extract ratio. The EMI EC is known as the apparent EC, which is denoted as ECA. Remember, when reporting salinity classes, these are always based on the saturated paste extract ECE. Other methods of determining EC should be reported in the notes section of your documentation. Odor is used to identify the presence of petrochemicals or hydrogen sulfide. The presence of gaseous or liquid gasoline can indicate contamination of the site. The presence of hydrogen sulfide, or that rotten egg smell, is associated with strongly reduced soil containing sulfides. A drop of 1 normal hydrochloric acid can help bring out the hydrogen sulfide smell if sulfides are present. Sometimes, the hydrogen sulfide smell can be detected without applying hydrochloric acid. Record the kind and relative intensity of any odor present. This job aid is designed to help you describe and record common chemical responses in the soil using NCSS guidelines. Some soil investigations may require additional field or laboratory chemical response measurements depending on conditions. An experienced soil scientist can help you develop your technique for collection and recording of measurements. As with any new skill, proficiency comes with practice. For more information and tips on sampling soils, please see our online NCSS training materials.